we have to show that all the things. So what is the line of impact? Line of impact I'm showing by red color. So let this be the line of impact. If you have a scale and if you have 1 rupee coin, you can manage. If you are finding very difficult, 1 rupee coin, you take it, or any lid of any bottle, different things. So this we have, let this be R. This distance will be R, no? And this will be R. What is this red color line? Line of impact. So in that direction only, the impulse will act here. So now what we have to do here? That impulse, I'll show it. So how the impulse will act here. So before collision, this is having a speed u. This was at rest, and the impulse will act in this direction. And the impulse on this sphere will act in this direction. Let me take this is theta. This is theta. First we'll find out what is sine theta will be. Sine theta is equal to r by 2r. Theta 30 degrees. Triangle you see. So what can be distance C1, C2? Center of this should be called 2r, no? So we do have a triangle. We'll get a triangle. So make observation every problem. A situation of like this, you are going to come across. And this is what we define theta. Okay, now I have some enough information. So first elastic collision I'm discussing. For elastic collision, what should happen to the sphere now? Exchange of velocity occurs along line of impact. So after impact, so directly straight away for elastic collision, first case I'm bringing it here. I think I'll diagrams I'm finding very difficult. Huh? Okay, able to see now? This is so after collision, what will happen to this x component of u cos theta? U cos theta will be given to this impulse. I'll take it out because after collision the impulse should not be there. So let's do one thing. So I'll directly straight away I'm concluding the problem. After collision, this will move with a velocity u cos theta, and this will move with a velocity u sin theta. And how do they move? They move perpendicular to each other. So what is the best way of doing this problem is along line of impact, perpendicular to line. So velocities of colliding objects perpendicular to line of impact should remain same, no? So here only we could have done that one. U sin theta. How u sin theta? Perpendicular to line of impact. So that component will not change. And since elastic collision, there will be exchange of velocities along line of impact occur because E equal to 1 and what is another condition given? E equal to 1 and also other condition is given that masses are same. So exchange of velocity occurs along line of impact. U cos theta was velocity of first sphere along line of impact. U sin theta perpendicular line of impact. U sin theta will not change. So this will be the velocity of sphere A. This will be the velocity of sphere B. And how VA and VB will be perpendicular. This is for E equal to 1. Let's see for second case, E between 0 and 1. Same diagram I should bring it, no? What will happen to that u sine theta for this P array? It will remain as it is. So therefore, what we have to do, we have to discuss the whole problem along line of impact, perpendicular to line of impact. Let me take total here. And then this one I'll erase it. Now see things clearly. I kept two diagrams in front of you. So this impulse also I'll take it out. Tell me now. So I'll bring this line perpendicular to line of impact. I think one problem, if you can understand, you can manage. Only one problem. How I should make this one. So there are two components are there. This is like a VA parallel. Sorry, VA perpendicular this is. And VA parallel. Masses are same. Will there be an exchange of velocity for E between 0 and 1? Need not know. We have to calculate separately. So after collision, so this will have VA parallel and this will be VB parallel. I'll take it to all these unnecessary things. What are VA parallel, VB parallel? This is line of impact. Tell me how you are going to find out unknown things. How many unknowns are there? Please do make observation. I have given, of course, they may appear a little bit small, but all the information I just dumped it here. The velocity of sphere A will be resultant of VA perpendicular, VA parallel. Whereas the velocity of sphere B only V parallel because only impulse will act during collision. No? This is during collision. This is after collision. This is before collision. This is after collision. There's a very basic problem. Almost every book they have given this particular thing. And there's a basic fundamental one. With the help of this, you can manage many other numericals. How to calculate VA parallel, VB parallel? Three unknowns are there. I need three equations. So let's go for one more. In what direction momentum is conserved? Any direction. But which direction I should conserve? Along line of impact. That'll be much easier, no? So I'll go for one by one. For second case, we are discussing conservation of linear momentum along line of impact. What was the initial momentum? Mu cos theta. Try to see here. Mu cos theta along line of, and what is this peer B? It was a test. In the diagram, everything is visible. So therefore, the equation will be mu cos theta is equal to mVA parallel plus mVB parallel. So therefore, u cos theta equal to VA parallel plus VB parallel. Now what is theta? Theta is 30 degrees. So we know value of that. So u root 3 by 2. Keep it here. So 2 unknown. Then coefficient of restitution formula. I'll take this is positive. So VB parallel, VA parallel by u cos theta minus 0. This is so EU root 3 by 2 VB parallel minus VA parallel. Equation 1. What is unknown thing? Okay, VA parallel, VB parallel, two unknowns are there. I'll add up these two. I'll get the unknown quantities. How to calculate that VA perpendicular? Anybody? Should be u sin theta only because how the impulse will act? How the impulse will act along line of impact. No? So u sin theta must remain same. So what should be VA perpendicular? VA perpendicular must be equal to u sin theta. adding up these two, equation 192. So it should be equal to how much this is? E plus 1 u root 3 should be equal to 2 VB parallel. So what is VB parallel? E plus 1 u root 3 by 2. Substitute that here, we'll get the VA parallel. Anybody VA parallel?
Sir, u root 3 by 4, right?
U root 3 by 4. Huh?
No, sir. VB parallel.
E must be there, no? Value of E.
Yes, sir. E plus 1 into u root 3 by 4 we'll get. B parallel.
VB parallel, huh? VA parallel. Huh?
VB parallel,
VB,
sir.
sir.
U root 3 by 4. Huh?
Yes.
Okay, 4 will be there. Yeah. Anybody VA parallel?
It is 1 minus E, sir. Into u root 3 by 4.
This much? Huh? Yeah. Center of mass, VCM will remain same, velocity of center of mass. VA perpendicular V, no? So from this, this is I think U by 2, no? Sine theta. So I can get the velocity of this. VA parallel whole square, VA perpendicular whole square. And what is VB? This is only VB. The whole sequence is what? I can only show this much, the window. So I think during collision diagram is very important. No, with that only we can manage everything. Try to see this. So whenever you get two-dimensional collision, what you should do, the line of impact becomes very important. Those component of velocities directed perpendicular to the line of impact will not change. Those component of velocities which are along line of impact, there'll be some changes will come due to impact here. So what we have to do before collision, we have to check it. Is there any component of velocities of colliding bodies perpendicular to line of impact? Those components will not change. So elastic, inelastic collision, things will be determined. How A will move? I think A will not move along line of impact or perpendicular to line of impact. A will move somewhere in this direction. Somewhere like this. And B will move along line of impact. If E equal to 1, A will move perpendicular to line of impact, B will move along line of impact. After collision now, the A will not move along line of impact or perpendicular, somewhere resultant. Here, it all depends on these two components. So this is what happens in carom board coins, no? You take a striker and the coin will have different radii. Here what meant they are identical, identical in shape, same radii, no? So therefore, what is the condition, no? So take two either white coins or black coins. Then unless, you see, it all depends upon how do they collide. So there's a very basic fundamental problem. So what is the conclusion now here? B will move, disk B moves along LOI and disk A I can't write any specific this one. Whereas here this is perpendicular to line of impact. So rather than I suggest you like a student, what will happen? Should draw a diagram during collision. The diagram will help you a lot during that collision. This diagram. This was the concept. Look at initial velocity and the impulse. With the help of that, you should trace it out. If the masses are different, in that case, it'll be like you can't write M here, M1 U cos theta, M1 VA parallel, M2 VB parallel. Then you check it. If mass is same and equal to 1, then exchange of velocity occurs, like what you have seen in this case. So what all you should do? Is it elastic, inelastic? Is it masses same or different? Then also the dimensions of the disk are same dimension or different dimension. So all these things have to be taken care. Now, inelastic collision, I have defined. No, what happened to this decrease in kinetic energy of system? Where do it will go? Delta K. There'll be loss in kinetic energy. You calculate final kinetic energy, initial kinetic energy. Final kinetic energy will be less than initial kinetic. Where do this kinetic energy gone? Converted into either deformation of bodies or heat, or it will be in the form of sound energy. In carom board, tell me what will happen. In elastic collision, you get a sound, no? When two coins they strike, tuck, you get a sound. So it's in elastic collision. Elastic collision, you don't get any sound, heat, or no deformation. So a troublesome question for students. Two bodies collided and a sound is generated. Tell me what is the collision? In elastic collision it is. In carom board, will they undergo deformation? No. There won't be deformation energy. It will be either, it will be maximum, it will be sound only. You can see then two coins when they strike, no, you get maximum sound. Shall we use elastic coins in carom board? Very conceptual question they'll ask you. In carom board, if a student to minimize sound effect or to eliminate sound effect, he'll bring elastic coins. Tell me what will happen there. Can you play carom board? No. you can't play. So suppose that the board, the side wall, no, if the elastic, tell me what when the striker, can it rebound? It cannot rebound with such a speed, no. So therefore, when your person, if you're manufacturing the coins and the side wall in carom board, you have to take care, no, the value of E, what happened? Should be equal to 1 or should not be equal to 1. If E equal to 1, it will undergo deformation. So E should not be equal to 1. And E equal to 0, what is the problem? It gets stuck if it directly moves. So like this, what when the wood should be designed there. It's not that is I'm telling this one. All the instruments here around you are based on science. Not just simply somebody has made it. Everything, some science is involved. You do make observation this time here. So you take some rubber disc something and try to that you make it a striker and try to play. Then you'll understand like what is the use of that E in the designing of carom board. So rather than this numericals in advance, they may test